a briefing for your lab report. So lab report 1 is about friction loss and bend in elbow. So the similar thing is that you have objective, introduction, theory, and so on. And then the theory on how to calculate apparatus use is this one. So basically, if you go into our lab, our Fluent lab, so you'll see this machine. You see this machine. So you'll be using this machine to calculate the losses at elbow. Okay, the one that we cover in the previous chapter, that we calculate the KL value. Okay, the KL value for all these elbow. Okay, so the experiment is about KL, the head loss coefficient. So, and this is a template that you should ready for the lab report. And this is how I give you marks. Okay, this is how you give you marks. So for all the report, you should start with the report cover sheet. Okay, report cover sheet. What I mean by report cover sheet is the one that you found inside this course guide, and then you go to the cover page. This one. Okay, so this cover page, you fill in experiment 1, date submitted when, okay, your name, your ID. Okay, then you sign. Okay. All right. Now, back to the lab report. So first, you attach the cover sheet. Second, introduction. Basically, you copy from introduction, objective, theory, apparatus, procedure, methodology is the same as the lab sheet. So from 1.1 until 7. Okay, until 7 is the same, and then this one you fill in the numbers here. Okay, so this is under calculation. Okay, calculation. How to do calculation? Okay, so these are the calculation guidelines. So I give you the calculation guidelines here. You read through. So for example, the first one, how you calculate volume fluid flow. Q, you take a volume divided by time. So you convert 3 liter, convert to meter cube. You get 0.3 divided by time that you recorded in the experiment. So this time I will give you in the lab sheet. So for example, I'll give you the raw data in the lab sheet. So all these data are given. You need to find what is friction head loss and loss coefficient, KB. Okay, so the calculation from step 1, step 2, step 3, step 4, step 5 was shown. So you need to do this calculation shown in your report. And then you fill in all this value. Okay, fill in this value. After that, you need to plot some graph. Okay, so this is another one. So the first experiment data is for elbow. The second one is bend. Okay, what is elbow and bend? Elbow and bend is this one. So this is elbow, this is bend. Okay, so what happened to the data if you run the experiment? You get 2 sets of data. One is for the elbow, one is for the bend. Okay, the apparatus we are using a code. So for the first one is P266 P6221 stroke 257. So another one also same, it's just only the configuration is a little bit different. Okay, so the calculation is given. So you need to do the calculation. After that, you need to plot some graph from the exam. For example, all these are instructions. You need to plot graph to find the results. Okay. Any question for the first lab report?
No, sir.
Okay, I think very clear. Okay. Then we go to the second lab report. Okay, second lab report is more on pump. Second lab report is on pump. We need to find the performance of different of pump. So basically, this is also one of your final exam question. Okay, so you need to go through this lab. So this one, the lab also you read through title until the all this theory part you read through, and you put in your report the same thing. Okay, we will cover a few type of pipe, a few type of pump here. So we will have centrifugal pump. This one. We will have a few things. Okay, so we read through and all this. So we will have in the experiment, this machine is inside our lab also. We call it a multi-fluid pump trainer. So inside here, we have a few pump. Okay, so we have centrifugal pump, we have gear pump. So as you can see here, there's a diagram here. So so for example, this one 11 is a gear pump. So meaning when you run the experiment, you turn on one of the pump and then you collect data. Okay, so you have centrifugal pump on 10. This is this one. And then semi-impeller pump and feeder pump. So you have 8, this one. So there's a picture for this one, so you can see accordingly. Okay, you compare this diagram and the number to this photo. Okay, at least you know what is the pump that you have. So these are the spec for centrifugal pump, gear pump, semi-open impeller pump, and multi-purpose amphibious pump. So this experiment is very simple. You just turn on one of the pump and then you collect data. Okay, you collect data. So they are reading on the machine here. You just read and then you collect. So again, the steps here you read through, and you need to key in and do some calculation. Okay, so there are a few sets. For example, maximum valve opening and then 55% valve opening. For the first experiment, you do 2, meaning open valve, maximum valve opening means you open 100%. And then the second one, you reduce to 85% valve opening. Same with centrifugal pump. Centrifugal pump, you have another one with 70%. Semi-open impeller pump is 85%, 70%. Multi-purpose amphibian pump also you do 3 set. Let me see. Okay. Then you need to do calculation. All right. So same, the structure of your report same. Cover sheet, introduction, objective, theory, apparatus, procedure. A to F you can copy and paste. All right. And then calculation, you need to show how you calculate the data. So I already give you some calculation here. You need to type yourself. So this one, you just need to show me how you calculate flow rate, volume, pressure difference, power. And I give you the raw data here. Okay, so for example, raw data for gear pump, 100%, 85%, 70%. You need to calculate the flow rate, volume, pressure difference, and also the power. So you need to calculate all the blank space here. So for centrifugal pump also you have 100%, 85% and 70%. For semi-open impeller also have three scenario and all the value here, and then you calculate. Okay. So after you calculate, you need to plot some graph also depending on the instruction that you found in this lab sheet here. Okay. Yeah, so this is basically about second experiment. And then the third one. Okay, the experiment 1 is due on this Friday. Yeah. Okay, experiment lab report for experiment 1 you need to submit by this Friday 5 p.m. No extension for the date. You need to pass up. For experiment number 2, due date is next Friday, which is 20 August. And then the third lab report is due on 27 August 5 p.m. So the third experiment is about Francis turbine. So you read through again, same 1.1 until, yeah, this is the turbine, Francis turbine, where you shoot a high jet, you shoot a high power jet, and then this one will turn, and then you calculate the rotation and so on. Okay, so you read through how Francis turbine works. Okay, so this is the machine that we use to conduct the experiment. So these are the value that we read from the experiment. So you control the handle here. This one will open the impeller here. So you move this one left to right, this one will open. Okay, will open. And then you read the reading over here. Okay, you read through. So this, you see all the data, how they shown. Okay. Okay, you read through the steps and so on. And then there are some calculation for you to do. So these are the template that you should ready for the experiment. And the same structure for lab report also. Cover sheet, introduction, objective, theory, apparatus, procedure. A to F you can copy and paste into your report. For calculation, you need to type yourself. You need to show how to do calculation. Result, if you result also, table, graph also need to generate yourself. Okay. Don't copy your friend's data. For example, if you calculate and you generate a graph using Excel, don't use the same Excel from your friend. If I pick up the similarity in your graph, I will, because if you use software to plot, it will show different kind of graph. Okay, the way you set your graph also will be different. Okay, so check your result graph. Don't get me catch your copyright trace. Don't copy your friend's graph. Discuss about your results. So these are the sample for calculation. For example, how to find torque, how to find volume flow rate, how to find input power, how to find efficiency. Okay, and this is the raw data for you to calculate. So L1, L2 plus L1 plus L2, then L1, L2, L3. What mean by L1, L2, L3 means you have the loading on the turbine itself. Meaning, just as a experiment. So if you run this experiment, the water jet will hit. Okay, the water will come in here. Okay, the gray color pipe here. You will go in and hit the impeller. This one will turn. Okay, this one will turn. Meaning, if I go to the 2D diagram that I showed you just now, here, this one. Okay, so if you open the water jet, this one will spin. Okay, it will hit this cup and it will spin. So same with this one. Okay, same with this one. This experiment, the water will go in here and hit the impeller. So it will turn, and then you can set the loading. So you have three, you can hit 3 loading there. Okay, so you can see here you have 3 switches. We have 1, 2, and 3. So if for the first set you on this one, you have the first load, then the second load. If the second experiment means you on these 2, off this one, and then the 3 load means you on these 3, and then you have this one. What I mean by the load means you have some stopping power. You use this controller to stop the blade from rotating. Okay, there's some stopping like a brake. You're pressing on the brake here, so it means you have a loading here. You press 1 means there's some loading on the turning speed here. So you have 1, 2, and 3 cases. You need to observe what is the parameter you can collect. Okay, so this is the raw data I given to you. You need to generate the torque value, output power, input power, and efficiency. So all these are the collected data that you need to convert into torque, output power, input, and efficiency. Okay, so this is the second means first data, second data, then get the average, first, second, and average, first, second, and average. But for engineering, normally we have 3 set. Okay, for engineering, normally we'll do 3 set, but the raw data I give you is only have 2. Okay, so same. So you can see this one is the gut opening 1. This is gut opening 2, gut opening 3, and so on. What mean by gut opening? Gut opening means you control the handle here. This handle, when you move this handle, this opening will open and close. Okay, if you move left to right, this one will open. Okay, all right. Any question for this 3 report?
So I have one question.
Yeah, go ahead.
The solutions, right,
Mm.
can be written on N or must type, sir?
You can use I will prefer you use type lah. Okay, you use typing. If you want to write also can, but make sure your handwritten is readable lah.
Okay, sir.
Okay, yeah. So I'm okay with handwritten, but normally I will encourage you to use Microsoft Word to generate the report.
Okay, sir.
Okay. All right. So let me stop the recording for this one.